Welcome to the DEFCAM. China's upcoming airborne early warning and control platform, the KJ-700, has been spotted conducting test flights, marking a significant step forward in Beijing's network-centric warfare, maritime dominance, and multi-domain surveillance capabilities. Designed as a naval variant of the KJ-500 series, the KJ-700 integrates advanced anti-stealth and anti-ballistic technologies to address evolving threats in contested regions, such as the South China Sea and Western Pacific. Built on the Y-9 airframe, a modernized derivative of the Soviet-era's AN-12 turboprop transport, the aircraft combines modular sensor architecture, passive detection systems, and networked warfare capabilities to deliver a no-compromise solution for the PLA Navy. Central to the KJ-700's design is its triple-layered radar architecture, engineered to detect stealth aircraft and ballistic missiles. The primary sensor is a rotodome-mounted distributed aperture radar operating in the X-band and S-band. The X-band provides high-resolution tracking of low-observable targets, such as stealth fighters, with a detection range of 170 kilometers against aircraft with a radar cross-section of 5 square meters. The S-band extends coverage to 600 kilometers for conventional aircraft and surface vessels, enabling broad-area surveillance. The rotodome incorporates 1,024 gallium nitride-based transmit-receive modules, each capable of 12 watts of peak power, offering superior efficiency and thermal management compared to older gallium arsenide systems. This dual-band configuration allows simultaneous air-to-air and maritime monitoring, critical for tracking carrier strike groups or hypersonic glide vehicles. Complementing the primary radar are side-looking L-band arrays embedded in rectangular fuselage fairings. Operating at 1 to 2 GHz, these arrays penetrate radar-absorbent materials used on advanced stealth platforms like the B-21 Raider, detecting low observable targets beyond 300 kilometers. The L-band's longer wavelength reduces susceptibility to shaping-based stealth techniques, providing a redundant detection layer against adversaries employing all-aspect stealth. This multi-frequency approach ensures resilience against electronic countermeasures and enhances tracking accuracy through sensor fusion. A groundbreaking feature of the KJ-700 is its integrated electro-optical infrared system, housed in a 1-meter diameter turret on the nose. This system includes a mid-wave infrared staring array with 1,024 by 1,024 pixels resolution and a 30-centimeter aperture telescope, enabling passive detection of thermal signatures from stealth aircraft and hypersonic missiles at distances up to 250 kilometers. The infrared sensor operates in the 3 to 5 micrometer spectrum, identifying engine exhaust plumes and aerodynamic heating effects without emitting detectable radio frequency signals. A laser rangefinder and large aperture CCD camera provide multispectral tracking, reducing reliance on active radar and mitigating vulnerability to anti-radiation missiles like the AIM-174B. Data from these sensors is fused using artificial intelligence algorithms, correlating radar cross-section anomalies with infrared signatures to classify targets with 95% accuracy. For ballistic missile defense, the KJ-700 employs a UHF-band pulse Doppler surveillance radar, optimized to detect hypersonic glide vehicles and distinguish warheads from decoys during mid-course flight. Adaptive waveform agility shifts frequencies every 50 milliseconds to counter jamming, while machine learning models trained on simulated trajectories prioritize threats in real time. During tests, the system demonstrated a 90% success rate in tracking DF-17 hypersonic missiles, enabling interceptions by HQ-19 anti-ballistic systems. This capability is vital for defending China's aircraft carriers and island outposts against precision strikes. The aircraft's electronic warfare suite enhances survivability through a digital radio frequency memory-based jammer, spoofing enemy radar-guided missiles across C to J bands. Cognitive electronic support measures passively collect emissions from adversarial platforms, such as the F-35s and APG-81 radar, and deploy tailored countermeasures. During joint exercises with J-20 stealth fighters, the KJ-700 successfully masked formations from simulated F-22 engagements, demonstrating its role as a force multiplier in contested airspace. Operationally, The KJ-700 leverages the Y9 airframe's endurance and versatility. Four WJ6C turboprop engines provide a 12-hour operational loiter time and 5,700-kilometer range, extendable via aerial refueling. The airframe's modular avionics architecture supports rapid software updates, with mission computers processing 2.5 teraflops to manage sensor fusion, threat analysis, and network-centric warfare. The Tactical Data Link 21 system enables real-time data sharing with J-15B carrier-based fighters, Type 055 destroyers, and land-based air defense systems, creating a unified kill chain. Strategic deployments focus on maritime choke points, such as the South China Sea, where the KJ-700's ability to operate from short, austere runways allows forward basing on islands like Woody Island and Subi Reef. During simulated conflict scenarios, KJ-700, directed J-16 fighters armed with PL-17 missiles achieved a 70% simulated kill rate against F-35Cs, underscoring its role in denying air superiority to adversaries. Challenges persist, particularly in supply chain resilience. Domestic production of gallium nitride modules lags behind global leaders, creating dependencies on Chinese state-owned enterprises like CETC. Additionally, the electro-optical system's effectiveness degrades by 30% under heavy cloud cover, necessitating redundant radar modes. Future upgrades aim to integrate quantum radar prototypes and hyperspectral imaging sensors by 2026, further closing detection gaps. The KJ-700 epitomizes China's shift toward integrated anti-access area denial strategies, merging advanced radar, passive detection, and networked warfare to counter stealth and hypersonic threats. As the PLA Navy accelerates deployments, the aircraft is poised to redefine aerial surveillance paradigms, challenging traditional stealth-centric doctrines and reinforcing China's ambitions as a maritime power. Thanks for watching. Stay tuned for the upcoming videos.